All right, now we want to classify metamorphic rocks. So when we classified igneous rocks, we said that it was going to be based on the mineral content and its texture. When we classified sedimentary rocks, it was based on its mineral content and its texture. So when we classify metamorphic rocks, it's going to be based on its mineral content and its texture. So in this picture here, it shows what a mineral turns into. Like, for example, the mineral olivine, when it's metamorphosized, turns into serpentine and chlorite. And then pyroxene also turns into serpentine, and but it also turns into amphibole, and it turns into feldspar. Don't worry about it. All right, so you're not going to have to memorize this. Although I do want you to notice quartz turns into quartz and calcite turns into calcite. That's going to be important. So now let's talk about the textures. So when it comes to metamorphic textures, it's either going to be non-foliated or it's going to be foliated. So let's first talk about foliated. In a foliated material, you start off with a protolith, so the thing that's going to become the metamorphic rock, and let's say that the crystals are not organized, so that they're oriented in different directions. But now let's say that it's subjected to a stress that is going to squeeze the protolith like this. Then what's going to happen is that these minerals are going to reorganize themselves like this. So this orientation of the crystals is going to be called foliation. And foliation is going to be very useful because we can use it to determine what direction was the stress being applied if we've got the igneous rock. Now, if it doesn't have this, it's going to be non-foliated. And so that means that that protolith was metamorphosized without any kind of directed stress. So directed stress causes foliation, but if there's no directed stress, then it's going to be non-foliated. So an example of that is going to be marble. So if you look at marble under the microscope, you can see that it's got these crystals that are going to be interlocking with each other, but it doesn't have any particular kind of pattern to it. So there's no orientation of the crystals. So that tells you that marble, when it formed, was not being squeezed like this stuff was. Now, when we talk about foliation, there's going to be grades of foliation, so that you can have stuff that's not squeezed very hard, and then it grades up into things that are really squeezed hard. So things that are low grade metamorphism first starts out with a foliation called, that makes shale. Okay, the crystals have reoriented themselves, but you can't see it with the naked eye. So with the naked eye, the rock is going to look blocky, but you're not going to be able to see individual crystals that have been oriented in shale. But then when you go to the next one, which is going to be phyllite, then you start to notice the orientation of the crystals. And then the next level, so if it's squeezed even harder, then it turns into a schist, and then finally it turns into a gneiss. So by the time it's a gneiss, then you actually have bands of crystals. So I'll show you some examples of this in just a moment. Okay, so here then is going to be our chart of metamorphic rocks. And so you can see that there are different ways of making metamorphic rocks. So you have regional metamorphism, You have contact metamorphism. You have hydrothermal metamorphism. You have burial metamorphism, fault metamorphism, and then impact metamorphism. So all of these are different ways of metamorphosizing a rock. And so we're going to take a break, and when we come back, we're going to go through each of these different kinds of methods.